Lately, there has been a surge of interest in using large language models, also known as LLMs, for tasks that are not related to text, language, or reasoning. One such area is tabular data processing, data that has structured rows and columns that power most business operations. It is not surprising that researchers and practitioners are exploring how LLMs can help with analyzing, modeling, and learning from this kind of data. Hi, I'm Kalyan Veermachineni, CEO and co-founder of Datacebo, the company behind the most powerful synthetic data generation platform, the Synthetic Data Vault. In this video, we'll take a closer look at the strengths and limitations of large language models and discuss how to use them effectively for tabular data. We'll focus specifically on the task of generating synthetic tabular data. Tabular data is really the heartbeat of most enterprises. It's the kind of data that gets recorded every time someone interacts with an organization's products or services, like when you visit a website or make a bank transaction. Think about a single bank transaction. It comes with a lot of details: the time it happened, which card was used, the account number, the person making the payment, the place, the amount, and plenty more. Each of these pieces become part of a table somewhere residing inside the organization. These datasets are often seen as time series too, because they capture a sequence of observations about an entity, giving a complete picture of how it changes over time. In fact, it's estimated that around 80% of all enterprise data is tabular. Each record usually captures a moment in time that people or systems are involved, and a bunch of other useful information about what actually happened. When it comes to learning from and processing tabular data, there are already plenty of well-established software tools. For example, libraries like scikit-learn and XGBoost are great for building predictive models, while tools like Synthetic Data Vault help create generative models. For data processing and manipulation, packages like pandas are the go-to choice. And there are many others that make working with tabular data efficient and powerful. So how can LLMs be helpful in this arena of building predictive generative models or simply data processing? Well, one of the most promising uses of LLMs is changing how we interact with these software tools. In the past, tools like these were mostly accessible only to developers who could write Python code. To make them more approachable for business users and domain experts, who are the people who understand the data and the insights needed, many products introduced user interfaces. These interfaces made it possible to upload data, build workflows, and even create dashboards without writing the code. These interfaces use the same software tools in the backend though. Even with these user interfaces, the challenge remained. There was never a single interface that worked perfectly for everyone. Building one that was flexible enough to handle most tasks while still being simple and intuitive turned out to be incredibly difficult. After all, we were still relying on the visual medium to let the user communicate with the tools and the systems. This is where LLMs can truly transform how we interact with software systems. Instead of relying on complex interfaces or writing code, users can simply communicate in natural language, the way they already think and work. The LLM's reasoning and interpretation abilities can translate those requests into precise commands for data processing. Imagine an agent designed for a specific task, like identifying anomalies in a time series. A user could just ask, "Can you look at my data and the signal and tell me if there are any anomalies?" The agent, already connected to the data and equipped with the right Python tools, would process the request and display the results, all without the user having to write a single line of code or learn a complicated user interface. In fact, a user can also ask LLM to deliver the code it used to generate the result, and it will deliver a fully functional Python code that it used. That's definitely a big step forward. You're no longer needed to install anything or write code. But it is important to remember that the real work is still being done by the underlying Python libraries, not the LLM itself.